Namaskar everyone. Welcome to the second day of the ATAL-FDP on AI and innovative engineering in healthcare, from smart implant to wearable tech. We are honored to introduce Dr. Sudeep Paul, who will be delivering his session on the topic Machine Learning for Early Detection of Parkinson's Disease. Dr. Paul is an associate professor at NIT Raipur. He received his PhD from IIT BHU Varanasi, followed by postdoctoral research at the University of Western Australia. With more than 60 published articles in reputed journals, over 50 conference papers, and 7 patents to his name, his expertise is impressive. Dr. Paul is also a senior member of IEEE and serves as the editor and author of several estimated publications. His achievements have been recognized through various awards, including the WFN Fellowship and the IBRO Travel Award. We consider it a privilege to have Dr. Paul with us today. I now invite Dr. Sudeep Paul to kindly present his session. Hand over to you, sir.
Thank you, Dr. Manisha, for your nice introduction. And thank you, Dr. Sandeep Jaiswal, sir, for inviting me for this ATAL workshop, for this ATAL training faculty development program. Today, I want to deliver the talk about the ML for the early detection of the Parkinson disease. I hope many of you are familiar at this moment that what is ML and what is the Parkinson disease. So without wastage of time, I am straightforward go to my slide for presentation. So first, you just confirm me whether my slide is visible perfectly. So my slide is visible. Can you confirm me?
Yes, it is visible.
Okay. And the audio is perfect?
Yeah, correct.
Okay, thank you so much, sir. So
So if you are muted.
sorry, so the course is basically focused for the AI and the innovative engineering. That's why I focused and I chose the topic of the ML for the early detection of Parkinson disease. All of you know that the Parkinson disease is a very common neurological disorder at this moment in globally as well as in India. So what is this disease actually? I will start from here very basic and I will go slow by slow towards the machine learning and the deep learning application of the Parkinson disease detection system. So it is basically the neurodegenerative disorder and it is mostly happen at the age of 50. But nowadays, the many survey has found that it is not only the elderly age disease, it can be caused in the age of 40 plus also. So we have to be very clear, has to be taken care that the disease, whatever is there, it is a neurological disorder. So that's why we have to be very assured in the earlier stage of life that it should not be there in any of us because it is a non-treatable disorder. So medicine is there, so many treatment is there, so many therapeutic aspect is there, but at the end of the day, the disease is untreatable. So it cannot be fully recovered at all. So what kind of motor symptoms and the non-motor symptoms are there for the Parkinson patient? So it is basically focused for the bradykinesia, tremor, rigidity, and the postural imbalance. So these are basically focused for the motor symptoms of our brain. But when you are considering the non-motor symptoms, that is basically for that various type of psychiatric disorder may arise. Because those who are the persons having the Parkinson, I am working in the Parkinson disease and two of my PhD scholars already awarded in the field of the Parkinson problem detection system. And so they have also did a lot of survey and also did a lot of extensive research on the Parkinson disease, how it can be and from where it can be and how it can be treatable, which type of techniques can be used for, what type of machines are there. We have developed so many machines in our lab. I'll show you that that is also patented. So that type of the psychiatric disorder may come in the earlier stage, also in the later stage of the life. So one of the most important symptoms is the sleep disorder. So most of the time it was found that in the survey cases that the sleep disorder can occur in the earlier stage. And this sleep disorder can cause to a later stage of the Parkinson problem. So when we are causing and when we are focusing the Parkinson, basically this study has been done in the northeastern region of our country, special focus to the Guwahati and the Meghalaya. And so this part, why we have chosen, because this is a hilly territory and lack of proper information, lack of proper supervision, lack of proper knowledge of that particular person, and lack of proper support, medical support, healthcare support in the northeastern region. So we did this survey, we did this study in the northeast region focus for. And what is actually the Parkinson problem arises in our brain? So it is basically focused for the substantia nigra region of our brain when the loss of dopamine. Dopamine is a biogenic amine like as in serotonin. So when this serotonin or dopamine level that is goes down below the normal level, then problem arises. Problem arises means the body is very rigid and it is non-functional for the motor symptoms. So we have surveyed and we got so many information from different patients aspect. And from there, we collected the data, and that data has been finally verified to the neurologist. And neurologist or the neuropsychiatrist has found that so many causes has come from the consumption of the well water, anxiety, fear, then the lack of knowledge. I already told you this type of problem is a basic problem for the Parkinson in the northeastern region. So how you can treat the Parkinson problem? So we have to go for the electrophysiological approach, that is for EEG, and that is focused for our brain activity. That means the bioelectrical activity of our brain. So this kind of technique when we are using to detect the Parkinson problem for cognitive decline is the most important thing. And then it is a real-time recording can be done. And then there is also a very good aspect is that is a spontaneous neurological background activity is there for EEG recording. And then we have come to the conclusion that there is a certain relationship of there from EEG with the EMG that is related with the muscle. Because when the Parkinson is there, the main effect is the neurology, but the effect is coming to the muscle. That is the muscle rigidity, the imbalance, then the different types of muscle contraction problem. So that is we have to determine the EMG also. So for that case, what we did, we also recorded the EMG signal from the Parkinson subject. Parkinson patient, obviously, after ethical approval and all from the different institute and our institute also. So after these things, so when we did, and then different type of motor symptoms like as the tremor, bradykinesia, rigidity, postural disbalance, that has been continuously monitored. In the line of direction of this time, similar line of direction of this, we are very fortunate that we got the different types of the patient, different symptoms of patient with having the different muscle motor related problem, and their mechanics has been properly identified, and also the gait pattern also we have recognized for the Parkinson patient. The walking pattern, their stability, they are walking, they are how they can walk, how much time they can walk from one side to another side, everything has to monitor in our lab. So once these things has been done, then we started our journey to the correlation between the EEG and EMG. Because to do the machine learning, we need certain data of the biological phenomena. That's why we have taken the data for EEG and also the EMG. These data will fit in the latter half of my presentation for the machine learning purposes. So what we did, that is basically for EEG for brain and EMG for muscle, when we connect together, that correlation took place, and that correlation we have to identify. Then I started my journey with my scholar that we have to do something that is a major correlation or major breakthrough can come in the field of Parkinson disease detection system when we compile together two different type of biological parameter, that is EEG and EMG. Then we were coming to a conclusion through the machine learning system that this is having some kind of early symptoms or the later late symptoms. So different type of stages are there in the Parkinson problem. We are considering about the stage 1 and stage 1.5. So stage 1 is the unilateral defect and stage 1.5 is the unilateral axial implication. So these are the two basic patterns that is usually happen in most of the cases for Parkinson patient after discussing with the neurologist in the hospital. So when you discuss with the neurologist, so they have identified that the stage 1 and stage 1.5 is the most common disorder for the Parkinson problem, and that most commonly affect towards the disease detection system. So these are our main motivation to finalize that what kind of problem is arising from the patient side and what kind of treatment that going for the neurologist side and what kind of technology or tool can be achieved or developed from the engineer side. That is our main motto. So the different type of scale that we have used, first one is the GDS scale. GDS scale was the 15-point scale. So it is starting from the 0 to normal, that is 0 to 4, that is normal range. 5 to 8 is the mild depression. 9 to 13 is the moderate depression. And 12 to 15 is the severe depression. So different depression level has been monitored through different scale parameter. Then we have also induced in the mini mental state examination, that is MMSE, that is 30-point grading scale is there. Then Webster scale having 30-point scale. Then we have we did the fatigue severity scale, that is FSS. It is a 1 to 7-point scale, and sometimes it is a higher than that also. That is 9 items can be stated from this particular clinical diagnosis. So when we did this kind of thing, we need some demographic, the data has to be calculated there, whether they are having any genetical problem or not, whether there is any family history for Parkinson disease or not, whether they are having any kind of alcohol intake or not. So we did a lot of tests has been done for the demographic data purposes. After getting certain result or after getting the certain data, we did the ANOVA. That is one way ANOVA we have did for our study, and we collected the different result as an MMSE we got the 0.96, then GDS we got the 0.81, then FSS we got the 0.78, and SpO2 we got the 0.88, and grip strength we got the 0.89. Grip strength plays a very vital role for this particular purposes. We did the Turkey-Hus test also, and most of the cases we got the alpha value is 0.05, almost it is a significance level, and the Q value is almost 15 and above for all the cases. So then the homogeneity test is also been done, and finally we comparison both the cases, the grip strength, then the FSS, GDS, and the MMSE. All the scale has been considered for the comparison purposes, and we got the box plot. Then we have to find out that depression is very, very common symptoms for the Parkinson. That I told you in the second slide of our study, that the non-motor symptoms like the psychiatric symptoms or the sleep disorder has to be there for depression level measurement system. So Parkinson patient having the more depressed than the normal cases. But the grip strength, if you can see, then you can easily find out that the grip strength is more valuable or more suitable for the control rather than the Parkinson. So Parkinson patient having a less amount of the grip strength simultaneously in the level of the control. So that means they are having a capacity, even though they are not hold a ball properly, they are not able to hold the proper glass of water. So there is a chances to break. So that's why the grip strength has been very, very minimum comparison to the control subjects. Then coming to the MMSE, if you can see the mini-mental state, then it is obviously the control signal is much more greater than the Parkinson, because the mini-mental state, when we are doing the 30-point grading system, then it is obviously giving the better result in comparison with the Parkinson subject. Then last we did the fatigue severity score, that is FSS. Then the fatigue is also more than the normal scale. Similar line of direction of our last slide, that is we did the depression. So here also the fatigue is more comparison with the control. So from this state we comparison the 5 different aspects. Obviously the SpO2 also, the SpO2 level is gradually goes down due to the lack of oxygen level in the blood. So that's why we have plotted, and we got the grip strength plays a very vital role in comparison with the other. But not only the grip strength, there is having the MMSE and also the SpO2. There is a equal in the almost in the Parkinson patient, all the parameters having the problem for the particular cases. But if you can see the normal cases, that is the control subject, the grip strength is very, very much harder than the normal system. So what is the conclusion of the study 1? So we did the ANOVA, and from this ANOVA we got the PD and the control value, that is always the P value is greater than the 0.05, that is the significance level. And we did the Turkey-Hurst test, that we got the SIG value of 1 for all the parameters. That means it is for the Parkinson and the healthy subjects in the comparison to the significance level of P greater than 0.05. And R square value is almost near to 1. So what the parameter, that is MMSE, GDS, FSS, SpO2 and the grip strength have been a very, very small, although very important tool for detection of the Parkinson disease for the early symptoms. Now, coming to the second part of a study, that is we have to calculate the sample size. Our sample size was 38. And the participants are from the, I already told you, that is basically focused for the Meghalaya region and from the Assam for Guwahati. So the Parkinson patient, those who are having to 1 to 1.5 stage for the upper limb tremor and unilateral damage, that only considered for the study. Then the control subject without Parkinson is not control. So biological disorder for above 50 years and less than 75 years only we have taken for the study. And then the subject who can communicate the voluntarily, then the data has been calculated. It is not a force to collect the data from none of us. So the exclusion criteria is that the less than 1 and greater than 1.5 was not considered, and less than 50 greater than 75 years of age was not considered for the study, and the subject having any kind of metallic implant, like as our pacemaker, like as a hip joint, knee joint, any bone, screw or plates, that was fracture repairment, so it was not considered for this particular study. So what the apparatus we have used, it is a biological biophysical parameter testing. We have used the AD instruments, PowerLab 60T, that is 2060, having the acquisition wire, dynamometer, then the grip strength analyzer, then the electrode. So rather than this, we have used different types of other equipments that I will show you. That is for EEG signal, having the we did the 2-channel EEG. That lead 1 and lead 2 we have calculated this the frontal zone, and lead 2, lead 3 calculated for the temporal zone, and ground electrode we have calculated the forehead. And for this is the picture of the calculation about data taken for the EEG data, and as well as the SpO2 data we have taken from this particular subject, because when you are taking the EEG, at a time you cannot take the EMG, because there can be the overlap or the noise can come to both the signals, so we avoid that kind of things. So only 2 types of signal we have collected together, because it is in resting state for EEG and the dynamometer for SpO2. But for the SpO2, we got, that is the graphical representation, that is for the healthy subjects. We got the frontal is very, very common, and SpO2 level is also very, very good from the healthy subjects. Frontal and temporal also very normal range. But for the Parkinson subject, if you can see, the SpO2 is almost 0, means not 0. It is going to less in comparison to the control subject. And as well as the frontal is also, the baseline is the distorted, and also the temporal has been the very less in amplitude and distorted also for the temporal region of the brain. So what we did, we did the EMG signal also for calculation for the Parkinson detection. We did the extension, that is lead 1, lead 2, and then the flexion and exterior extension we have used. Then lead 2 and lead 3, that is the channel 2, we have used the ulnarius muscle and the capri albinus muscle. Then the ground electrode we have used the left elbow, and sometimes we have used the radius ulna. So what we did the hand dynamometer in one hand, and we did the muscle relaxation and contraction in the other hand. So we have measured the EMG as well as the grip strength together, because when I do the contraction, the signal will come. I'll show you in the next slide. When the contraction will be there, that is for the Parkinson subject, the contraction is very, very minimum. But when we will see that contraction for the healthy subject, it is a very, very good in the contraction and relaxation mode. So if the contraction means the almost is the high in amplitude, but relaxation is the low in amplitude. For Parkinson, if you can see, the amplitude level is gradually less for the grip strength also, and for the muscle 1 and muscle 2, both the cases, and the grip strength and comparison with the muscle, all the cases has been goes down to the amplitude. So what we did after getting all kind of reporting, that is for EEG to two hemisphere, then we got the 4-channel, then EMG also, grip strength also, dynamometer result also, SpO2 results also. So then we coming to the actual corresponds, that is the actual scenario, what is coming to the both the patients, that is EEG and EMG. If you can see that the EMG for Parkinson is a very higher range in comparison to the normal in the normal for control subject. So that means their muscle is not properly contracted and relaxation is not taking place. It is a haphazard in nature. But for the normal or the control subject, it is a very systematic. So we can say that from this graph that the muscle relaxation, muscle rigidity is very tremendously affected for Parkinson patient. So what type of filtration technique that we have used for collecting the EEG and EMG data calculation purposes? We have the cutoff frequency of 1 to 50 Hertz for EEG and sampling frequency of 240 Hertz, as well as for EMG it is 5 to 500 Hertz and sampling frequency of 1000 Hertz. So there are almost 10 parameters that we have calculated from EEG, and also the 10 parameters we have calculated for EMG. For Lyapunov exponent, Shannon entropy, inverse Lyapunov exponent, autocorrelation, kurtosis, variance, root mean square, median frequency, mean frequency, standard deviation, all is calculated for feature extraction technique. For EMG also we have calculated the power, standard deviation, and the root mean square, wavelength, variance, median frequency, mean frequency, then percentage of MVC, all we have calculated for this particular study. So after these things, it is coming the classification, because when we get the different data from the EEG, from EMG, from grip strength, from the SpO2, hand dynamometer, so different parameters we got, and from EEG now starts from the feature extraction. So what type of feature extraction we did? First, we did the Lyapunov exponent. It is an attractor. It is a nonlinear dynamics. So basically, we did the different type of control in the temporal subject and is a Parkinson subject. Then also the frontal for control and frontal for Parkinson. If you can see in the normal eye, you cannot visualize what the graph looks like. But if I can show you the data, then you will easily find it out that what is the result is getting. The healthy subject, what we are getting, that the frontal is 2.82, that is an attractor, for temporal is 3.19. But for Lyapunov exponent for inverse cases, it's just opposite to the frontal is very less comparison to the temporal is very less comparison to the frontal. So that means the temporal having a very high the cohesive bonding to the neuronal effect rather than the temporal. But in the Parkinson subject, it is just reverse. It is the frontal and then temporal. So that means the temporal having a very less chance for the binding of the each attractor in the space, and simultaneously the temporal region having the very less in comparison to the frontal for the Parkinson disease. So after getting this data, we have plotted the box plot for Parkinson and as well as the control subject for different types, different regions of our brain, for temporal as well as the frontal. What we did, the box plot said that there is a temporal region having a much more significance than the frontal region, and reverse for the Parkinson disease. So after these things, we did the autocorrelation function. That autocorrelation functions is also giving the high impact for the normal cases with comparison to the Parkinson subject. And this is also giving the almost in the straight line as a sinusoidal waveform. But for the Parkinson cases, that amplitude is slightly moving higher side for the frontal region. But for the temporal region, if you can see the Parkinson subject, which is showing in the left side of the diagram, it is the sinusoidal waveform is there, but the control subject, it is having the sinusoidal, but there is some sort of distortion is there. So that means the autocorrelation function is also saying that there is some distortion effect is there in the brain. So after that thing, we are considered to the percentage of MVC, that is the maximal voluntary contraction of the muscle. So the formula that we have used, and using the formula we have calculated for healthy is 81, and for the Parkinson we have calculated for 54. That means the percentage MVC is also going to very less for the Parkinson subject. Now coming to the different feature extraction that I told you just 2-3 slides back, we comparison to all the data, and out of all the data when you are calculated, this root mean square giving the very smart the form in comparison to the Parkinson, but for the power is also very high in Parkinson is very less. Then we can calculated the modified median frequency is very high for healthy subject in comparison to the Parkinson subject. Now coming to the comparison of all the parameter for EMG cases also for feature extraction, then you can obviously find it out the root mean square value is almost 350, close to 350, and as well as the modified median frequency is almost close to 350 for this particular subject. So complete structural the position that we got from the EMG and EEG, that is two biological signals that we got from the Parkinson as well as the healthy subject. And after getting this data, we started our calculation to the classification purposes. We started the feed-forward network in the training, and this input layer having the EEG and as well as the EMG. There are almost 10 parameters is used for individual features for EEG, and for EMG we are giving the input, and hidden layer we have fitted almost 50 parameter we have fitted in the hidden layer. Then the output layer will give you the exact information that what is that there is a Parkinson disease or there is a control or healthy subject is there. So what type of the network parameter? This is just basic introduction. That is the training is almost 70%, validation 15%, and testing 15% for the multi-layer perception. Then we did the only EEG, only EMG, and both ENG both together. Then we did the different type of training phases, the TRAN-DM, then TRAN-SG, and TRAN-LM. So different type of system that we have used, and by using the different type of training function, that first one is the TRAN-DM, we have did the EEG, EMG, and both together. We are calculated the epoch, and classification rate is almost 50, 60, 70, and this percentage of the accuracy that we got. R value is almost very higher than almost 0.9 we got for EEG, and for EMG also we got 0.87. But for second function that we got the train SSG, that is having that is a scale conjugate gradient that we having also the almost the classification rate is 80 and more than 80. Also some cases 87 we got when we did the EEG and EMG together. But for the TRAN-LM, when we did together, for EEG and EMG, when we did together, we got the accuracy level is classification rate is almost 100% most of the cases. And also the R value is close to 1. So that means from the study, we have found that we have significance that when we did the EEG itself and when we did the EMG itself, then there is a very high consideration of the EAG, ENG, and EEG for this particular purposes. And after these things, when the EEG has been done, for the R value is 0.7143 and EMG value is 0.8447, and altogether when it is coming, that the value is coming 0.9972. That means it is giving a very sophisticated result for the EEG and EMG correlation purposes. So now from these results that we have got from TRAN-LM have giving the more accurate result comparison to the EEG and EMG, that is giving the when you do together, it giving the overall compression result of 0.9972. So what he did from this study 2, that Lyapunov exponent for the Parkinson's subject for the temporal region is less than the frontal brain, while the healthy subject has been more improved than the temporal rather than the control subject. And just reverse for the inverse Lyapunov exponent, I am not going in that. From the autocorrelation function, we conclude that the neuronal excitation is there. For systematic oscillations is hampered for the Parkinson subject that we got, because the systematic oscillation like as the pure sinusoidal waveform was not present for the Parkinson subject most of the cases. And Shannon entropy for Parkinson shows there is an neuronal complexity is there. So that percentage of higher value of percentage MBC also we got for the normal cases rather than the Parkinson subject. We got the 81% and we got the 54 for the Parkinson. So from this result, the conclusion is that for different type of nonlinear dynamics we have used for detection of the Parkinson subject early detection, then this type of problem may arise, and this type of problem can be overcome by using these techniques, because when you do the machine learning, this type of particular things can be the useful phenomena for the training purposes. So now coming to the EMG prospect, it is a healthier person having the higher value of the root mean square, wavelength value, and the power rather than the Parkinson subject, because obviously it is a very common phenomena for Parkinson subject having a very less amount of power in their hand and the muscle, and that's why muscle got rigid in the lateral stage. And when we did the ANN, that is artificial neural network, together for EEG and EMG, it is giving the almost 98.8% of accuracy rate when we coming together, or correlation together between EEG and EMG, both together for the Parkinson and normal cases. So what is the third experiment of our study, that is the radiological interpretation? We did the MRI for the Parkinson as well as the normal subject, and MRI data also been taken care for our study. We saw the brain structural changes, the dopamine deposition changes, and various changes in the brain, and what type of PD biomarker that has been identified for diagnosis for the early detection. And based on these things, you can easily diagnose that the Parkinson patient and the normal patient in the earlier symptoms cases. Now, when you do the dopamine deposition for the MRI cases, we see that the dopamine deposition is very, very less for the Parkinson subject rather than the normal, because it is a brain MRI for Parkinson, this left side figure, and it is it's a small glimpse of the MRI signal, that how much is the small amount of space is there for the dopamine. It is the substantia nigra actually. It is a bean-shaped structure is there. It is a substantia nigra region of our brain. And but when the deposition is there for the normal cases for the dopamine, it is a normal brain MRI signal. It is a shallow tail, the appearance should be there. It is a tail-like structure, that's why it is called swallow-like trail for the healthy subject, and you can easily identify for the color structure. I hope I am having the picture. I don't have the picture right now. So this figure having the bean shape structure or the tail shape structure having a very beautiful color, it will come in blue color for the color MRI. So it will give the clear cut identification for the small amount of the dopamine level and larger amount of dopamine level or dopamine deposition in the substantia nigra region. And from that point of view, we can early diagnose, or the radiologist can intervene the patient for the Parkinson subject. You can have a Parkinson in the earlier stage or the later stage of the life. Now, after these things, what we did the GUI we have designed in our lab, and that is already copyrighted and patented also. So what we did the different type of signal we have collected from different subjects, and different subjects and different parameters also we have collected. We collected the autocorrelation, we collected the Lyapunov exponent, we collected the frequency bands, then the frequency domain signal we have collected, then different types of feature extraction we have collected. So after that, we got the value, and then there is a window is there, blue color. You can see that there is a browse for EMG signal. We can easily calculate the real time, because this GUI has been calculated to calculate the real time signal. Because once the patient having the different EEG, from the EEG you have to calculate the different parameter, and the EMG automatically the system will calculate the different parameter. So no need to calculate separately, or no need to calculate, or no need to go to different sections of the hospital to calculate or to evaluate if you're having the Parkinson or not. So the real-time EEG and EMG, if we're having, so that particular signal, if you can upload it automatically, the GUI will give you are having the stage 1 Parkinson, or you are having the stage 2 Parkinson. That means the Parkinson has been identified either is 1, 1.5, it's 2, 2.5, 3, 3.5. That is different scale. I told you only we are considering of 1 and 1.5. So we have tested, and we have found that approximately 500 subjects we have tested in the northeastern site, and mostly we have found that either 0 or 1. So mostly they are in the line of the direction that they are in the earlier stage of the Parkinson. But there are several cases has been reported in the hospital that the latter stage has been found it out, that 1.5 or 2, 2.5. What is the conclusion 3? That is the third conclusion of our study, that we got the different type of swallowtail appearance for the dopamine level deposition of our brain in the substantia nigra region. And that's why the dopamine level deposition has been very, very goes down for the normal cases, the Parkinson subject, but for the swallowtail activity is completely visible for the normal cases. If you do for the CT or MRI or the PET scan, that will give you more impression about these particular cases. But this can be a novel tool for detection of the Parkinson subject or Parkinson parameter in the earlier stage. So what should be the whole summary of our research? the demographic data that we have identified for the suffering of the Parkinson is the most common non-smoker cases history more than 20 years and well consumption of water. That is our first identification. Then we got that it was found that the people related to the field work, like in the cultivation, even though the industrial sector area has prone to the Parkinson is very, very much more. And so the cultivation when the attack of the Parkinson are more, they are very continuous contact with the insecticide and the pesticide. And mini mental state examination, that is MMSE of the Parkinson disease, is very less in comparison to the healthy subject. And generic depressive state, that is called GDS scale, having the two group compared to the Parkinson as well as the normal cases. So there is also a chance to identify the Parkinson having a very lower dose or higher dose that has to be calculated. And then we have found the different types of percentage MVC, also a parameter that is called maximum voluntary contraction, also give the highlight in the research that is having the muscle contraction and relaxation power has been very less or high. So after doing all these things, then we did the SpO2 level also. SpO2 level for Parkinson is very, very less because the oxygen saturation goes down in comparison to the normal subject. Lyapunov exponent will give you a very, very interesting feedback for the frontal region of the brain, but for the temporal region, having given the spatiotemporal region correlation is one of the major factor for neuronal factor. And for autocorrelation function is also concluded that the neuronal excitation and the systemic oscillation hampered for Parkinson compared with the healthy one. Increased Shannon entropy of the Parkinson patient has been there for neuronal complexity. And then the electromyography like EMG has been found the healthy person in comparison to the root mean square and the waveform length. Then the power and modified power frequency has been rather than the Parkinson patient. Hence, a disease progress for the muscle become the more weakened and more difficult to move in their limb. So finally, we can go for the radiological intervention also. We got the substantia nigra region for the Parkinson patient is very, very less amount of dopamine. That's why the swallowtail activity is very, very less amount. But for normal cases, it is very high. Lastly, we go for the artificial neural network that is called machine learning that we have used for these particular purposes. And we got that the EEG and EMG particular cases is 98.8% compared to the other. And these particular cases, when we did the single for EEG and single for EMG, that is also not much more important aspect of this particular features compared with the other features. Finally, we designed the GUI for the MATLAB graphical interface, and that will give us the exact guideline how the patient condition is and what should be the treatment policy and planning for the next course of action for the neurological point of view. So this kind of instrument that we have developed in my lab, that is the tremor identification device for Parkinson disease that was patented, Indian patent, and two algorithms that we have developed for the online Parkinson prediction system. And second one is the algorithm for the early detection of the Parkinson system. It is also copyrighted. Both the algorithms are copyrighted because based on these things, we have designed the GUI, and also the scholars are working in the lab for this particular the early symptoms of the Parkinson disease detection system. And tremor identification device, recently we have submitted the proposal for startup, and hopefully it will come soon for the device for commercialization purposes. So this way, thank you for your standby hearing and collaboration for future academia and industry. Thank you so much.
Participants, if you have any question, please ask. Dr. Paul, we have one question in chat box.
Yeah, just wait.
Kavita Jindal, she's asking, is there any relation between Parkinson's disease and ICP, intracorneal pressure?
Oh, it is there. Okay. So the intracranial pressure is not directly related with the Parkinson patient, but indirect effect is there because when we are considering the cranial pressure, it is the cranial nerve is involved with that particular things, but it is not directly linked with the ICP with the Parkinson disease. There is no link direct relation is there.
Okay. Any other question, participants?
Paul, am I audible?
Yes.
Dr. Paul, you have done the studies on the where the participants were people from Northeast. have any other studies been done in other geographies as well? And what was the result over
So
there?
far, sir, we didn't do it. We because my previous institution was in Nehu, Northeastern Hill University. So I am focusing the study at the Chhattisgarh also. So we are developing our lab in this particular dimension. So soon we will start the similar line of direction in the Chhattisgarh.
Other researchers all across the world, if you have any knowledge.
I hope there are so many studies has been done in different places, but I didn't found that the hilly territorial has the much more affected in the Parkinson rather than the plain land.
And one other question, listening to your presentation, it was very fascinating actually. It came out that depression is almost a precursor to Parkinson. Is that a
Yeah,
fair impression?
yeah.
Depression is depression
Depression. Yeah,
precedes.
yeah. It's a very common symptoms. It's a very common symptom. Stress and depression is a very common symptoms for Parkinson because those who are having Parkinson, there is a less chance to revive. I already told it is a non-recovery and non-treatable disorder. So when you are having the Parkinson subject or Parkinson patient, the later stage of life, they are having a high chance for depression and they are having the sleep disorder also. So they have to be continuous the counseling with the psychiatrist and they have to guide it how to do the activity, day-to-day activity. They continuously depressed. Yeah.
And the disease comes after 50 because you have taken 50 to 75 as age group.
Yeah. So nowadays study has been done for 70 to 50 to 75, but most of the cases we have found that the age behind 55 to 65 is the major range for having the Parkinson.
Okay. Thank you, sir. Thank you.
Hello.
पाच 15 रुपये द्या ना. माझा पेन संपायला आलाय मग रिफिल पेट्रोलचा. माझा पेन संपायला आलाय. मला नवीन पेन घ्यायचंय मग रिफिलेबलच घेऊन टाकतो ना. रिफिल किती भेटते पेनची? 5 ला पण माझ्याकडे रिफिलेबल.
One question in chat box. Can you say what was PD identify methods and how to find new methods?
Is that a question? I'm not audible.
Sorry. Dr. Paul, there is one question in chat box.
Oh, okay. Can you say what type of PD identify method? Oh, PD identification method is first you have to identify the tremor. There is the hand tremor, movement tremor, or mouth tremor, or lip tremor, or there is a different type of tremor in our body. So first you have to identify the tremor, and then you have to identify their muscle rigidity and the muscle, how much is the muscle, the contraction relaxation power, and then you have to identify the option is the EEG. So EEG will give you the clear-cut identification that you are having the Parkinson or not. Then if you can go for the higher level of the confirmatory test, then you go for the MRI or the SPECT, that is you can give the confirmatory test purposes. Yeah.
Dr. Paul, if somebody is suspecting that he or she may be having a Parkinson trait, what online tools he or she can use actually, or his near and dear
Online
ones
tools
can?
at this moment there is no online tools is there, but she can do some kind of therapy that she used to do the different of therapeutic approach they can follow to concentrate and to reduce level of depression and the stress, and to do certain small amount of exercise for muscle rigidity and stability that can be improved, but the complete improvement is very rare cases.
Okay. Thank you.
Any other question?
Sir, I have one question.
Yeah, please.
Sir, right now I'm working on the early detection of the Parkinson disease based on the detection feeds.
Okay.
And I have found some biomarkers that are the FDA approved. But my question is that can we use these marker apart from these FDA approved biomarkers? Means the government approved FDA markers. Apart from this, can I use these markers for the early detection of the Parkinson disease?
You can use it, but it should be properly ethically approved.
Yes, sir.
So I have shared my
But-
email ID in the chat box. If you have any collaboration or any kind of joint work is required, you can contact me.
Yes, sir. But earlier that are the public that biomarkers are the earlier reported by the some research paper also.
Then you can use it by citing that reference.
Okay.
Any other questions, please? So, Dr. Paul, if you want to choose any model for from machine learning, so which model is suitable for classification of this Parkinson's?
Basically, sir,
Identifying or
machine learning
diagnosis of it?
purposes is basic model is if you can go for these things, then best model is LSTM.
All the participants are requested to complete the session feedback form just posted in the chat box. Thank you, sir.
Yeah, thank you so much. Thank you,
Thank you,
Dr.
thank you,
Sandeep sir,
thank you.
and thank you, Dr. Manisha.
Uh,
Thank you.
Dear participants, we are taking 10-minute break for the next session. You all are requested to rejoin the session at 7 p.m.
Thank you, Dr. Paul, for your wonderful session. I
Yeah.
think the participants had a deep insights of the Parkinson's and their method to classification.
Yeah.
And thank you very much.
Thank you, sir. If any students want to do certain work in the field of Parkinson or any other neurological disorder, so you can give my contact details. So I am
Sure,
really
sure.
happy to help them.
We will share your email ID with my participants.
Yeah,
so
I
that
have
they
already
can
shared my
want-
email ID. It is not only for Parkinson because I did the stroke model also. I did Parkinson. Now I'm working in the schizophrenia. So if anybody is working interested, so they can means contact me. Yeah. Thank you.
Okay, so participants, we will be back at 7 for the second session. Thank you, Dr. Paul.
Thank you, sir. Thank you.